In 3.3, we're going to look at piecewise defined functions. And these are just functions that have different formulas based on the different parts of their domain. So our first problem, we can see that the change is going to happen at 3. Okay, let's graph the left side. So these are for x values that are less than 3. So I'm going to graph y is equal to 2x minus 2. So y is equal to 2x minus 2. We know that the y-intercept is negative 2. And we know that our slope is 2. So we know our slope is 2 over 1. So 2 up and 1 to the right will be right here. We can keep with that pattern. 2 up, 1 to the right. And we can sketch that line in. Now, we have to consider what happens, though, at 3. So if we enter into 3, right, we're going to be right here. But we don't want this value. We want everything up to this value. So I'm going to enter a open circle. Okay? And then I can draw my line. Now, I want to consider what happens on the other side. Okay? So anywhere to the right where it's greater than or equal to 3, I'm going to graph the line 1/3 x plus 1. There are a couple of ways you can do this. You could just graph y is equal to 1/3 x plus 1. Let me just show you this way. So this would be a y-intercept of 1, and I'm going to go up 1 over 3, up 1 over 3, up 1 over 3, right? That's one way I could do it. And I could draw that line in, but I'm only going to draw it in starting at where 3, x is equal to 3. Even though we know the way we constructed our line was by drawing it off the y-axis, we cannot use the left side until we're greater than or equal to 3. Okay? That's one way. Another way you can construct that right side is just to give yourself a table and to give yourself a value of 3. So if x is 3, then y is going to be 2. Okay, let me give myself one more point. I'm going to give myself one point that's to the right or greater than or equal to 3. So I'm going to say 6. So 6 divided by 3 is 2, plus 1 is 3. And I can graph those 2 points. So 3, 2, and then 6, 6, 3. Okay, and then I could just draw a straight line using those 2 points. Either way, you're going to get the same line. It's just a different way of getting it. Okay, let's look at our next problem. So for this problem, when x is equal to 0 is going to be where it's going to change. Okay, so I'm going to consider that. So anywhere left of the yellow line, these are all my values that are less than or equal to 0. And anything on my right, these are going to be my values that are greater than 0. Okay, so let's first graph the left side. We know this is simply a parent function of absolute value, and it's going to be shifted down 1. Okay, so we could think of it like this. If I graph the whole function, it would be something like this. But I don't want the whole function. I only want the left side. So I'm only going to graph that side. Okay, now let's be very careful of what happens at 0. On this problem, it says if x is less than or equal to 0, I'm going to use absolute value of x minus 1. So I'm going to use a closed circle here because it says less than or equal. So at 0, we're going to use the absolute value of x minus 1 for our output. Okay, now if it's greater than 0, we're going to use x minus 3. So let's graph that side. So I would have a y-intercept of negative 3, and I'm going to be going up 1 over 1, because if I have x minus 3 is equal to y, we know our slope is 1. We can think of it as 1 over 1, and we know that our y-intercept is negative 3. Okay? So if I were to pencil that in, I could draw one there, and then go up 1 over 1. Now, I have to be aware, very aware of what happens at 0. When x is equal to 0, we want to make sure it uses the left function. So when x is equal to 0, we want to make sure we put a big open circle here because we don't want to use the right function. We want to use the absolute value of x minus 1. Let's look at our next problem. This piecewise function, we're going to make sure that when x is less than or equal to 1, we're going to use x squared as our output. And when x is greater than 1, we're going to use negative 3x plus 2. Let's go ahead and I draw myself a little reminder that this is going to be the break. For values when x is less than or equal to 1, we're going to use x squared. We know how to graph that. That's simply a parabola. I'm going to sketch that in for now. What happens when x is equal to 1? Is it going to use the top function or the bottom function? Well, because it has the word less than or equal, we know we're going to use the top function. So we're going to draw a closed circle here. Let's see what happens when we're greater than 1. So when we're greater than 1, we're going to use the equation y is equal to negative 3x plus 2. So our m is negative 3, and our y-intercept is 2. So we can write this as negative 3 over 1 and go down 3 to the right 1. So let's graph this. So our y-intercept would be a 2. And we're going to go down 3 and then over 1. Down 3 and over 1. Okay? Now, I don't want to use my values, though, that are less than 1. Okay? So I'm only going to use these values. And at 1, I'm going to use the left equation. So I want to make sure I put a big open circle here. When I'm finally done, I want to make sure that I've removed any kind of construction lines that I've used. You can use them to help you draw the line. Just make sure you erase them. And then make sure you clearly note what happens at that 1 point. So when x is 1, I can clearly see that the closed dot is my left function, which would be x squared. Okay? My next problem has 2 different places that I want to be aware of. Negative 1, when x is negative 1, and when x is 2. So depending on whether you're in this region, we're going to use this equation. If you're in this region, you're going to use this equation, okay? And if you're in the third region, you're going to use our third equation, okay? So let's look at each of these. So let's first look at when we have x's that are less than negative 1. I construct my line. My y is equal to negative 2x minus 2 line. So my slope is negative 2. I'm going to go down 2 into the right one, and my y-intercept is negative 2. So I went ahead and graphed the point negative 2 on the y-axis, and I'm going to go down 2 to the right 1. I could also go up 2 and then to the left 1. So you can see my line. Now, this is only for values that are left of my yellow line here where x is less than negative 1. So I'm going to go ahead and draw this part in. The other part I use to construct it, but I'm not going to actually use it. And I'm going to do a big open circle here because of it says less than. So at negative 1, it does not choose negative 2x minus 2 equal y to be its output. Okay, it does not have an output of negative 2x minus 2. So I'm going to erase all those other construction points. In my middle region, where x is between negative 1 and 2, I'm going to use an output of x plus 1. So y is equal to x plus 1. So let's graph that line. So for this line, we're going to have a y-intercept of 1 and a slope of 1 because the coefficient is 1 in front of the x. So we could say that's going to be up 1 to the right 1. So let's graph our y-intercept, okay, of 1, and then we're going to go up 1 over 1. So I can draw my line. Okay, now let's look at each end of this region. So when x is equal to -1, we would use this equation. And -1 plus 1 would give me 0. Wow, so that's the same thing. When I have x is equal to -1, in this equation, it also gives me 0. That's okay. That just means our line is going to continue here. Okay, so we can remove that open circle because now we know that this line actually is just continuous at that point. Now let's check the right end of our line. So that would be when x is equal to 2. Well, if it's equal to 2, we're going to use this region because it says that we're looking at values that are less than or equal to 2, and they'll fall in the second region. Okay, so this is also a closed circle here. Okay, so let's do our third region, which would be the right of the x is equal to 2. So these are values that are x greater than 2. Let's graph -3/2 x plus 6. So we know we have a y-intercept of 6, and we have a slope of -3/2. So we can graph this now. Now we're only going to use this for values that are to the right of 2, so values that have an x greater than 2. So I'm only going to use this portion of my line. Now I want to point out that I've used different colors here, and I've used different construction lines to show you how it works. But in the end, you can just draw one curve in the same color. It doesn't really matter. So let's just show you what that looks like. So I just drew it in so you can see what it looks like in one color. You may notice that there are no open circles. And why does that happen? That's because our function on both sides approaches the same point. Now let's write the piecewise function from the graph. So we can see that we're going to have two different regions. We're going to have y equal to two different things. One when x is less than 0, and one when x is greater than or equal to 0. Do you see why that happens? You can see right here, this is where there's a discontinuity. Something's changing there. So we're going to write the equation for our left line and then the equation for our right line. The equation on our left has a y-intercept of 0. Our slope is going to be down 2 over 1, down 2, and then to the right 1. So our slope will be -2 over 1, or just -2. Okay? Now let's write the equation for the line on the right. Once again, we can use that y-intercept of -2 and find the slope. So to go from this point to this point, we'd go up 1 to the right 2. So our equation will be 1/2 x. So let's clean this up and write a little neater. So I wrote my piecewise function. I added the word if, so now it's very clear. You can see that if x is less than 0, I'm going to say y is equal to -2x. And if x is greater than or equal to 0, I'll use y is equal to 1/2 x. The next function, there's a discontinuity at 4. So we're looking for if x is less than or equal to 4 for the left side, and if x is greater than 4 for my right side. And I can tell that because it's an open circle, so I know it's going to be the ones on the right will be greater than 4, but not including that 4. So let's go ahead and write the equations for each of one of these. Now, when f is less than or equal to 4, we can see it's clearly going to be a parabola, which is a square function. So we're going to use a parent function of x squared. Instead of the vertex being at 0, 0, we can see now it's shifted. It's gone right 3 and it's gone down 1. So we're going to need to change our parent function from just plain old x squared to x minus 3 squared minus 1. On the right side, we can see is the square root function. So our parent function is this, but it's been shifted. Instead of the end of the function happening at 0, 0, it's happening now at 4, 1. So it went right 4 and it went up 1. So we're going to need to adapt our parent function. So we're going to say minus 4, x minus 4, and then we're going to add 1. So this is our piecewise function for. Jacob is a former high school football player who landed a summer job as an assistant football coach with his high school. The head coach will pay Jacob $12.50 per hour to run drills for the team if he works up to 20 hours per week. So you can see I've modeled that with my first expression, 12.5x, and I've written in where my domain will be. The coach has agreed that Jacob will make $60 per week in addition to $15 per hour if he works more than 20 hours to a maximum of 45 hours, which would include maintaining the football field. So you can see the second part of my piecewise function, I've written when my domain is between 20 and 45. So now I've written my piecewise function, and this will tell me my salary based on the number of hours. For part B, it asks us to graph the function with your graphing calculator. I am not going to ask you to do the graphing calculator. You may use paper and just a regular grid. But I want to show you, in case you want to use the graphing calculator, how you would do it. So you would need to enter in your two equations into y1 and y2. So our first one we know is 12.5x. And our second one is 60 plus 15x. Now we have to tell the calculator where the domain is for each of these expressions. So let's tab up to 1. Whenever I want to do this, I'll always say divided by, and then I'll put a parentheses. That's signaling to the calculator that you are going to use some kind of domain restriction. So I'm going to say here, when x is greater than or equal to 0, so I'll find a greater and or equal symbol by saying second math, and I'll press number 4. Now I'm breaking this compound inequality into two pieces, so I'm going to say and, so I'll say second math, and I'll tab over to logic, and I'll press 1. Now I'm going to do my second part, which is x is less than or equal to 20. So x, second math, and I'm going to say less than or equal, and then 20. I always want to close it with a parentheses. Let's do the second one. So once again, I'll say divide, parentheses. This could be broken into two inequalities where x is greater than 20. So x, second math, I'll use the greater than symbol, 3, and 20. I'll use the word and, so second math, tab to logic, and hit 1. And then x has to be less than or equal to 45. So x, second math, less than or equal is 6, 45. And then I'll always use my closed parentheses. So I have now entered into my calculator my piecewise function. Now, if I want to graph this, I need to adjust my window. We know that a standard window is only 10 to the right, 10 up, 10 down, and 10 to the left. So my smallest x is 0 here, and my largest is 45. So I'm going to adjust my window. I'm going to say from 0 to 50. If you want to show the whole way, you could type in -5, and that will clearly include your 0, be a little bit to the left of it. My y minimum, well, the smallest salary would be 0. Okay. Once again, if I want to, I could say -5 if I really want to see it. And then my y max, now if I multiply 40, that'd be 45, that's my maximum number of hours, times 60 plus 15x, I get a really big number. I'm just going to say 1,000 because I know it's less than that. Okay? And then I'm going to hit graph, and you can see now the piecewise function. Now, if you notice, it does not show the open circle or the closed circle. So you just need to be aware that where the open and the closed circle are. Part C asks me how much Jacob will earn if he works 18 hours. A couple different ways we can do this. First of all, we can just look and say, well, 18 is definitely going to use this part of my piecewise function because it's between 0 and 20. So his salary would be 12.5 times 18 is $225. Or if you did go ahead and enter that into your calculator, the piecewise defined function, you can use your calculator. One way you can do it is you can say second graph. This gives you a table. And you can just tab down till x is 18, and you'll see that y1 would be 225. Our next part says, if Jacob were to earn $630, how many hours would he have worked? Well, let's just check out our piecewise function. If he works 20 hours, then the most he'll ever earn here is, what, 20 times 12.5? We're talking $250, right? So we definitely are in this part of our function. So we can say 630 is equal to 60 plus 15x, and we can solve for x. I calculate that he'd have to work 38 hours to earn $630. If you're uncomfortable using the calculator for the piecewise defined function, don't worry. As long as you can do it on paper, you're fine. However, you really want to learn how to use your calculator and you want to be able to enter it. Page 265 walks you through the steps very clearly, and you might want to take a peek at that. Paragraph.